Welcome to long-form content of Tech Bytes and News. This is a compilation on latest news and articles featured on Hacker News. You can find the original links of articles in the description. Please like and subscribe to support future content. Hope you enjoy.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into Google's latest announcement, the general availability of Gemini 2.0. Exciting stuff!
Absolutely. I've been following Gemini's development closely. So what are the key takeaways from this release?
Well, the big news is that Gemini 2.0 Flash is now generally available through the Gemini API in Google AI Studio and Vertex AI. Developers can finally build production applications with it.
That's a huge step. What about the performance improvements? I recall the earlier Flash model being praised for its speed and efficiency.
Yeah, they've significantly improved performance on key benchmarks. And get this, image generation and text-to-speech capabilities are coming soon. It's going to be a game changer.
I see. And what about the other models mentioned? There was something about a Pro version, right?
Right. They've also released Gemini 2.0 Pro, experimentally, their best model yet for coding and complex prompts. It boasts a massive 2 million token context window that's double Flash's capacity. Plus, it can integrate with tools like Google Search and code execution.
Wow, 2 million tokens. That's impressive. What about the cost aspect? Is this going to be expensive for developers?
Good question. They also introduced Gemini 2.0 Flashlight, designed for cost efficiency. It's in public preview now, and it offers better quality than the 1.5 Flash at the same speed and cost. Think of it as a budget-friendly powerhouse.
That's smart, offering options for different budgets and needs. But what about safety and security? These models are getting increasingly powerful, so that's a major concern.
Absolutely. Google highlights their investment in safety measures. They've used reinforcement learning techniques where Gemini critiques its own responses, improving accuracy and handling of sensitive prompts. They're also using automated red teaming to identify and mitigate security risks, including indirect prompt injection attacks. A very important aspect.
That's reassuring to hear. So overall, this release seems like a significant leap forward for Gemini. It's not just incremental improvements, but a whole suite of models catering to different use cases and budgets.
Precisely. It's a comprehensive update, demonstrating Google's commitment to pushing the boundaries of AI. The availability of these models across multiple platforms, the Gemini app, AI Studio, and Vertex AI, makes them accessible to a wider range of users and developers. It's a very exciting time for AI.
I agree. This is a major step forward for the field. Thanks for breaking down this exciting news for us.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for listening. And we'll catch you next time with more exciting updates from the world of technology. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a fascinating and frankly infuriating story. The FAA's hiring scandal. It's a tale of ambition, thwarted dreams, and a systemic failure that's still reverberating through the aviation industry. Let's get started.
I'm eager to hear this. The title alone suggests a major mess. What's the core issue? Was it just incompetence or something more sinister?
It's more than incompetence. It's a complex web of factors. At the heart of it, the FAA abruptly changed its air traffic controller hiring process in 2013. They invalidated previous aptitude tests, introduced a bizarre biographical questionnaire, and essentially sidelined the Collegiate Training Initiative, CTI, programs designed to train future controllers. This left thousands of qualified candidates, many who'd invested years and significant resources, out in the cold.
Wow, that sounds incredibly unfair. So what was the reasoning behind this drastic change? Was it a cost-cutting measure?
Not exactly. The FAA claimed it was trying to increase diversity within the air traffic control workforce, which historically lacked representation from minority groups. They argued that the old aptitude test, while effective at predicting job performance, had an adverse impact on minority applicants. So they replaced it with a new system, hoping to achieve a better balance between diversity and performance.
But did they achieve that balance? Or did they just create a bigger problem?
That's the million-dollar question. The new biographical questionnaire was deeply flawed. It was filled with oddly weighted questions. And there was even evidence of cheating facilitated by a member of the National Black Coalition of Federal Aviation Employees, NBCFAE. The result? Thousands of qualified CTI graduates, many of them minorities, were rejected, while the overall quality of applicants likely decreased. The whole thing was a mess.
So the attempt to increase diversity backfired spectacularly? And what about the CTI programs? They were just abandoned?
Essentially, yes. The FAA abruptly cut off communication with the CTI schools, leaving them in the dark and undermining their years of successful training. The schools, many of which were at community colleges, were left scrambling to justify their existence and explain to their students why their hard work didn't guarantee a job.
This sounds like a major scandal. Did anyone try to hold the FAA accountable?
Absolutely. There was a class action lawsuit, congressional inquiries, and even FOIA requests that went all the way to the Supreme Court. It took years, but eventually Congress passed legislation overturning the use of the biographical questionnaire and requiring the FAA to give affected individuals a chance to reapply. But the damage was done. The whole process exposed a deep-seated lack of transparency and accountability within the FAA.
And what about the long-term consequences? Did this hiring scandal contribute to the current air traffic controller shortage?
Almost certainly. The scandal disrupted the pipeline, reduced the quality of applicants, and damaged the relationship between the FAA and its training partners. Current air traffic controllers have spoken about increased workloads and fatigue due to the shortage, which is a serious safety concern. The article even suggests that the FAA's actions may have been deliberate, a way to create a crisis that could justify privatization.
This is a shocking story. It highlights the unintended consequences of well-intentioned but poorly executed diversity initiatives. And the political fallout is just as messy, with the recent plane crash bringing the scandal back into the spotlight.
Exactly. The author does a great job of highlighting the partisan aspects of the issue, noting how both Democrats and Republicans have failed to adequately address the scandal. It's a cautionary tale about the importance of transparency, accountability, and getting the details right when implementing policy changes, especially those with significant consequences for individuals and national safety. It's a complex issue with no easy answers, and the author's call for a nuanced, bipartisan approach is crucial.
A truly compelling and disturbing story. Thanks for breaking it down for us. It's a must-listen for anyone interested in aviation, government, or just good investigative journalism.
You're welcome. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll catch you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving deep into the fascinating world of U.S. egg prices, specifically the historical data and forecasts available on Trading Economics. Get ready for some excellent insights.
I'm all ears. So what's the big picture here? Is the price of eggs going up, down, sideways, or doing the Macarena?
Ha. Well, it's not quite the Macarena, but it's definitely interesting. According to Trading Economics, the price of eggs in the U.S. has seen a significant increase since the beginning of 2025, a whopping 22.03%, or $1 per dozen.
Wow, that's a pretty steep climb. What's driving this price surge? Is it the great egg shortage of 2025?
That's a great question. The data source, USDA, doesn't explicitly state the cause, but it's likely a complex interplay of factors. We're talking supply chain issues, inflation, and possibly even increased demand. It's a multifaceted problem.
Right, makes sense. So what does the future hold for egg prices? Are we looking at a continued upward trend, or is there a chance of a price correction?
Trading Economics models and analyst expectations predict a price of $7.66 per dozen yen by the end of this quarter, and a further increase to $9.67 per dozen yen within the next year. That's a pretty bold prediction, but it's based on their models, so we'll have to see how accurate it is.
$9 a dozen? That's getting expensive. I wonder how that will impact consumers. Will people start substituting eggs for something else? Nactals. Maybe tofu scramble will become the new breakfast craze?
That's a very valid concern. The impact on consumers could be significant. We might see a shift in consumer behavior, with people opting for cheaper alternatives or reducing their egg consumption. The market will certainly adapt, but it will be interesting to see how.
Absolutely. And what about the data itself? How reliable is the information provided by trading economics? Is it sourced from reputable organizations?
That's a crucial point. The data is sourced from the USDA, which is a highly respected source. However, it's important to remember that these are forecasts, and there's always a degree of uncertainty involved. External factors could easily influence the actual prices.
I see. So it's not a crystal ball, but a pretty sophisticated prediction based on historical data and current trends. Interesting. What other commodities does trading economics cover?
Oh, they cover a wide range, from other agricultural products like beef, poultry, and wheat, to energy commodities like crude oil and natural gas, to precious metals like gold and silver. They even have data on cryptocurrencies and various market indices. It's a comprehensive resource for anyone interested in commodity markets.
That's impressive. It seems like a valuable tool for traders, investors, and anyone interested in economic trends. Thanks for shedding light on this. I never thought I'd be so fascinated by egg prices.
My pleasure. And remember, listeners, this is just a snapshot of the data available on Trading Economics. If you want to delve deeper into the world of U.S. egg prices or any other commodity, be sure to check out their website. Until next time, this has been Tech Bytes and News. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into ASCII-Doc, a powerful markup language that's poised to challenge Markdown's dominance. Exciting stuff!
I'm really keen to hear this. Markdown's been my go-to, but I've heard whispers about ASCII-Doc's superior capabilities. What's the main advantage?
Well, Markdown's great for its simplicity and widespread support, no doubt. But, as your documentation grows, it starts showing its limitations. Think complex tables, footnotes, cross-references. Markdown often needs extensions, leading to compatibility issues. ASCII-Doc handles all that natively.
So ASCII-Doc is like Markdown, but on steroids, right? I love that analogy.
Exactly. It's built for complex documentation from the ground up. It's got a unified ecosystem, unlike Markdown's many dialects. No more battling inconsistencies.
That's a huge win for maintainability, especially with version control. How does it handle things like document organization?
Brilliantly. You can include or reference multiple ASCII-Doc files, keeping large projects neatly organized. Imagine breaking down a user guide into smaller, manageable chunks. It's all about modularity.
And what about metadata? I always hate fiddling with separate config files.
ASCII-Doc handles that elegantly. You embed metadata directly in the document header, title, author, date, all in one place. No extra YAML needed. Clean and efficient.
That's a huge time saver. What about the actual writing process? Is the syntax drastically different?
Not really. Basic text formatting, bold, italic, monospaced, is very similar to Markdown. Lists are also intuitive, and the ordered lists automatically renumber themselves if you rearrange items. Smart!
And tables? Markdown tables can be a nightmare sometimes.
ASCII-Doc tables are a dream. A simple grid syntax, with each row on its own line. This makes diffs in Git incredibly clean and easy to understand. A game changer.
I see. So it's not just about the syntax, it's about the overall workflow and maintainability. What about attributes? I'm intrigued.
Attributes are reusable variables. Define something once, and it updates everywhere. Perfect for version numbers, URLs, anything that repeats. Very handy.
That sounds incredibly powerful for managing multiple versions of a document. How about handling really large projects?
ASCII-Doc shines here. The include directive lets you split your docs into separate files and include them dynamically. You can even have conditional content based on attributes, creating different outputs, like beginner versus advanced guides, from a single source. Amazing!
That's impressive. But how do you actually export the finished document? I imagine it involves command line tools.
You can use the command line, but there's a better way. ADOC Studio is an editor that bundles everything. Writing, organizing, and exporting. It handles attributes, formats, HTML, PDF, etc., and style sheets, all in a user-friendly interface. No more terminal headaches.
So ADOC Studio streamlines the entire process. It sounds like a significant improvement over using just the command line. What about the cost?
There's a 14-day free trial, then it's a subscription model, monthly or annually. But considering the time saved and the improved workflow, it might be a worthwhile investment for serious documentation projects. Definitely worth considering.
And finally, how does this all integrate with Git?
Perfectly. Because a SciDoc is plain text, Git handles it beautifully. Collaborate effortlessly, branch safely, track history. All the benefits of docs as code. A true win-win.
This has been a fantastic overview. A SciDoc seems like a compelling alternative to Markdown, especially for larger, more complex projects. Thanks for shedding light on this.
My pleasure. And remember, for more in-depth information, check out the resources linked in the show notes. Happy documenting, everyone. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating blog post about running archive team's Warrior project within a Kubernetes cluster. It's a really cool application of containerization for a worthwhile cause.
Right, I'm eager to hear this. The blog post mentions using VMs initially, but then shifting to Kubernetes. What were the main motivations behind that switch?
Yeah, the author initially used a Proxmox VM, following a readily available guide. But that limited concurrency to 6 jobs per Warrior instance. This was a bottleneck, especially during the co-host archival effort. The move to Kubernetes offered scalability, allowing for more concurrent jobs.
Makes sense. So they found a Docker file on GitHub, but had to adapt the Kubernetes manifests, right? What were the key modifications?
The original manifests used a static node port, assuming only one instance. The author made it more dynamic, using environment variables for configuration. Crucially, they added an in-memory empty-dir for data storage. This was essential because their Kubernetes nodes have relatively small disks, only around 16 gigabytes. Using memory avoids disk space issues and actually speeds things up.
So essentially, they traded disk I/O for memory usage. But wouldn't that lead to frequent ohm kills?
That was the initial thought, yes. They set a memory limit just above the empty dir size, so if the volume fills up, the pod gets OM killed, and Kubernetes replaces it. However, a later update revealed a surprising detail. Kubernetes doesn't actually clear the in-memory volume on ohm kill. That's unexpected.
Wow, that's a significant finding. So the initial assumption about ohm kill behavior was incorrect. What other changes were made after this discovery?
The author discovered the grab container images, which are optimized for archiving and don't include a web UI logging to std out instead. This simplifies things considerably. They also integrated a Python script to monitor pod performance, pulling metrics from the Kubernetes API. It's a quick and dirty solution, but it works well for monitoring memory usage.
So a shift from a single, potentially overloaded Warrior instance to a scalable, Kubernetes-managed deployment with improved monitoring. And the discovery of the grab images further streamlined the process. It sounds like a really efficient solution.
Absolutely. The blog post also links to the author's Kubernetes manifests and the improved Python monitoring script. It's a great example of how Kubernetes can be used to efficiently manage resource-intensive tasks, especially for collaborative projects like archive teams' efforts. And it highlights the importance of iterative development and adapting to unexpected behavior.
Definitely. It's a testament to the power of open-source collaboration and the flexibility of Kubernetes. A great case study for anyone looking to deploy similar applications. Thanks for breaking this down for us.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll catch you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving into a fascinating new approach to visualizing U.S. county data, a hexagonal tiled cartogram. It's a game changer, really. Exciting stuff.
A hexagonal tiled cartogram? That sounds intriguing. I'm familiar with cartograms, but hexagons? What's the advantage?
Exactly. The brilliance lies in the hexagons. They tile perfectly, unlike squares, eliminating those pesky gaps and corner effects. Each county gets equal visual weight, regardless of its actual geographic size. This lets us focus on the data itself. Population density, economic indicators, you name it, without the distortion of uneven county sizes.
So instead of a county's area representing its population, each county is a hexagon. And other visual cues like color or size show the actual data? Clever.
Precisely. Think about it. A sprawling rural county and a densely packed urban county. On a regular map, the rural county dominates visually, even if its population is much smaller. But in this cartogram, the visual emphasis shifts to population density, making comparisons much clearer.
I see. And this isn't entirely new, right? Hexagonal tiling has been used for state-level maps before?
Absolutely. State-level hex maps are common, simplifying comparisons and highlighting trends. But extending this to the county level is a huge leap, offering much finer granularity. It's a significant advancement.
So what kind of data can we visualize with this? Just population density?
Oh no, not just population density. We can overlay all sorts of data. Unemployment rates, median income, vaccination rates, even election results. The uniform hexagon size allows for direct, unbiased comparisons across regions. It's incredibly versatile.
That's powerful. It addresses the large county small vote problem in election maps, right? The visual representation becomes much more balanced.
Exactly. And the filtering capabilities are amazing. You can zoom in on specific states or regions, reducing visual clutter and focusing on specific areas of interest. Imagine analyzing New England's population density in isolation. It's incredibly useful for local government officials too.
I do have a slight concern though. The article mentions that the placement of the hexagons is somewhat subjective. Doesn't that introduce a degree of bias?
That's a valid point. While the size and shape are standardized, the arrangement of the hexagons does involve some subjective decisions. However, the overall benefit of clearer data visualization likely outweighs this minor limitation, especially considering the alternative of distorted geographic maps. It's a trade-off, I suppose.
I see your point. It's a trade-off between perfect accuracy and clear visualization. Overall, this hexagonal cartogram seems like a significant improvement for visualizing county-level data. It's a really innovative approach.
Absolutely. It's a powerful tool for anyone working with U.S. county data, from researchers and policymakers to journalists and data enthusiasts. It's a fresh perspective, a new way of seeing the data, and that's what makes it so exciting. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into hexagonal cartograms. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving into a fascinating piece on modern C++, a language celebrating over 4 decades of evolution. It's titled 21st Century C++, and it's a real eye-opener. The author, Bjarne Stroustrup himself, highlights how many developers are still using C++ like it's 1999, missing out on major advancements.
Wow, Bjarne Stroustrup himself. That's amazing. So what are these key advancements he's talking about? Is it just about new features? Or is there a deeper shift in how we should approach C++ programming?
It's a fundamental shift, actually. He emphasizes 5 core concepts for building performant, type-safe, and flexible C++ software: resource management, lifetime management, error handling, modularity, and generic programming. Think of it as a complete overhaul of best practices.
Resource management sounds crucial. Is this about avoiding memory leaks?
Exactly. He champions RAII. Resource acquisition is initialization, using constructors and destructors to automatically manage resources. No more manual memory management, leading to fewer leaks and more robust code. He even shows examples using STD, vector and custom vector classes to illustrate this. It's all about letting the language handle the nitty-gritty.
I see. And lifetime management? Is that related?
Absolutely. It's about controlling the lifespan of objects, using constructors, destructors, copy, and move operations. This is key for preventing dangling pointers and other nasty surprises. He even discusses how to avoid redundant copies and functions, optimizing performance without sacrificing safety.
That's impressive. What about error handling? Is it still all about error codes?
Not at all. He advocates for a combination of error codes for local errors and exceptions for more serious, unexpected ones. He argues that exceptions, surprisingly, can be more efficient than the traditional error code approach. It's a more elegant and safer way to handle errors.
Interesting. And what about modularity? I've always struggled with header files in C++.
That's where modules come in. They replace the old #include system, offering order-independent imports and preventing those subtle dependency bugs that plague header files. The performance gains are significant too, with compile times drastically reduced. He gives a compelling example showing a 25x speedup.
That's a game changer. And finally, generic programming?
That's all about writing code that works for various types without sacrificing type safety. He uses concepts to specify requirements for template parameters, ensuring that the compiler catches type errors at compile time. Lambda expressions also play a big role, making the code more concise and readable. It's all about writing more expressive and efficient code.
So it's not just about learning new features, but adopting a new philosophy?
Precisely. Stroustrup emphasizes the importance of guidelines and profiles to enforce these modern practices. He highlights the C++ core guidelines, a set of rules designed to promote safer and more efficient C++ code. These guidelines, along with enforcement mechanisms called profiles, are crucial for ensuring that code adheres to these modern standards.
This sounds like a complete paradigm shift. It's not just about adding new features, but about fundamentally changing how we write C++ code.
Exactly. It's about embracing the evolution of C++ and leaving behind outdated practices. It's about writing safer, more efficient, and more maintainable code. This article is a must-read for any serious C++ developer. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the world of modern C++. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a fascinating story. A developer's 5-year journey building a web app, culminating in a Hacker News post, and, well, a single dollar. It's a tale of perseverance, technological evolution, and the sometimes surprising realities of launching a project. Intriguing, right?
Absolutely. 5 years is a significant commitment. What were the core challenges this developer faced?
Oh, where do I even begin? The biggest hurdle was, arguably, scope creep. He started with a simple goal, a minimalist music composition app. But the tech stack, oh boy, went through C++, Electron with CoffeeScript and React, Riot, JS, a self-made state management library, ES6, TypeScript, MobX, Flow, Material UI, and even explored various rendering methods, from divs to Canvas to Easel.js, React Pixie, and finally WebGL. It's a whirlwind tour of JavaScript frameworks.
Wow. So, a classic case of over-engineering? Did he ever consider a simpler approach?
He did. In retrospect, he admits several times that choosing a simpler tech stack earlier would have saved him years. The constant refactoring, rewriting, and chasing the latest shiny technology definitely added to the development time. He even mentions that he now appreciates the value of unstyled UI libraries, a stark contrast to his earlier obsession with Material UI.
I see. Interesting. So despite all the technical hurdles, he finally launched. What was the Hacker News reception like?
Well, it wasn't exactly viral. He got a few comments, some upvotes, and eventually, one GitHub sponsor for a single dollar a month. It's a humbling experience, but he takes it in stride. He focuses on the positive aspects, the global reach, the feedback from users, and the steady, albeit slow, growth of his user base. He even got some contributions on GitHub.
A single dollar, huh? That's anticlimactic, but also strangely relatable. It highlights the challenges of monetization, especially for open source projects. Did he have any monetization strategy beyond GitHub sponsors?
Yes, he added ads through Carbon, a tech-focused ad platform, which brings in about $100 a year. Small, but it's something. And he's clearly not discouraged. He sees the launch as a major milestone, a stepping stone towards his ultimate goal, building a collaborative music composition platform.
That's a really ambitious long-term vision. It's inspiring to see someone stick with a project for so long, even with the initial lack of significant financial reward. It speaks volumes about his passion for music and software development.
Exactly. The story isn't just about the technical challenges. It's about the journey, the learning process, and the unwavering dedication to a personal project. It's a reminder that even seemingly small successes can be incredibly rewarding, especially when fueled by passion. And who knows, maybe that $1 sponsor will become a major investor someday.
Absolutely. A great story of perseverance and passion. Thanks for sharing this with us.
You're welcome. And to our listeners, thanks for tuning in to Tech Bytes and News. We hope you enjoyed this deep dive into the world of software development and the sometimes unexpected rewards of long-term projects. Have a great day, and we'll catch you next time.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the explosive growth of Julia and Julia Hub. The numbers are astounding. Did you see the 494% increase in Julia discourse views? That's over 500 million views.
Whoa, that's incredible. And it's not just views. GitHub stars for Julia and its packages are up over 400%. Citations of core Julia papers are up nearly 400%. And the number of registered Julia packages has more than tripled. It's a massive success story.
Absolutely. It's a testament to the power and elegance of the Julia language. The fact that YouTube views for the Julia channel are up 342% shows the growing interest in learning and using Julia. Even news articles mentioning Julia or Julia Hub have seen a significant jump, over 200%.
And the improvements to Julia itself. From version 1.4 to 1.11, we've seen a huge leap in features and capabilities. Each release has brought significant enhancements, making Julia even more powerful and versatile. I'm particularly excited about the advancements in performance and usability.
Me too. And let's not forget JuliaCon. The growth there is phenomenal. The first virtual JuliaCon had almost 30,000 participants. That's mind-blowing. And in-person attendance has more than doubled since the pre-pandemic days.
Right. The quality of presentations has also improved dramatically. It's become a major event in the scientific computing world. But the growth isn't just limited to the community. Julia Hub itself has expanded significantly.
Exactly. Julia Hub now has over 100 employees across 6 continents. They've also been incredibly active in contributing to the Julia ecosystem, conducting 85 free webinars, and contributing countless hours of development. It's a truly impressive commitment to open source.
Their product offerings are equally impressive. Julia Hub itself provides a powerful platform for high-performance computing. Then there's Julia Sim, a game changer for model-based design, significantly reducing simulation times. And the specialized tools like Julia Sim batteries and Julia Sim HVAC are addressing critical needs in various industries.
I see. Interesting. I think Julia Sim batteries, with its ability to simulate battery lifetimes 150,000 times faster than real-time, is particularly noteworthy. That kind of speed-up is transformative for battery research and development. And Pumas, for pharmaceutical modeling and simulation, is another powerful tool.
I agree, but I think it's important to note that while the growth is spectacular, the article mentions that this is just the beginning. There's still much more to come from both Julia and Julia Hub. The future looks incredibly bright.
Absolutely. The article ends on a high note, promising continued innovation and growth. It's exciting to be part of this community and witness this incredible journey. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the world of Julia and Julia Hub. Goodbye, and have a great day.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating exploration of medieval physics, specifically the surprisingly accurate range calculations for a trebuchet.
A trebuchet, huh? Sounds like a fun challenge. I'm ready to get technical. What's the core argument here?
The author cleverly uses energy conservation and basic kinematic principles to estimate a trebuchet's range, without getting bogged down in complex mechanical details. It's a brilliant simplification.
So, they're not doing a full-blown mechanical simulation? That's smart. How do they approach the problem then?
They start with potential energy, the energy stored in the raised counterweight. They use the formula delta E equals mg delta h, where m is the counterweight mass, g is gravity, and delta h is the height change. Ingenious.
Right, potential energy converted to kinetic energy of the projectile. But they don't calculate the exact energy transfer, right? There are losses, right?
Exactly. They assume an 80% efficiency, acknowledging energy losses due to friction and the trebuchet's mechanics. This is a realistic approach, It makes the calculation more manageable.
I see. So they get a launch velocity. Then what? How do they get the range?
This is where it gets really interesting. Instead of diving straight into calculus, they use a clever graphical approach to derive the equations of motion. They visualize the area under acceleration time and velocity time graphs to find the distance traveled.
That's a fantastic pedagogical approach. It makes the concepts much more intuitive, doesn't it? So they calculate the time of flight first, right?
Precisely. They first calculate the time of flight assuming a horizontal launch, then use that to find the horizontal range. The surprising result? The range is independent of the planet's gravity.
Wait, what? That's counterintuitive. How is that possible? I mean, gravity pulls the projectile down, right? Shouldn't stronger gravity mean a shorter range?
That's the beautiful part. The author argues that gravity affects both the launch and the fall. A stronger gravity leads to a faster launch, but also a quicker fall. These effects cancel each other out, resulting in the same range, regardless of the gravitational acceleration. Amazing!
That's mind-blowing. So they then refine the calculation for a 45-degree launch angle, which maximizes the range, right? And they use the quadratic formula to solve for the time of flight in this case?
Yes. The 45-degree launch angle is a classic optimization problem. And yes, they correctly use the quadratic formula to solve for the time of flight, which is now more complex because of the vertical component of the initial velocity. The final result is a range of around 210 meters.
And that's remarkably close to historical accounts, isn't it? Impressive.
Indeed. The author's estimations are surprisingly accurate, considering the simplifications made. It showcases the power of clever approximations and intuitive physics reasoning. This is a great example of how to approach complex problems with elegant solutions.
Absolutely. This article is a fantastic blend of historical context, insightful physics, and clear explanations. It's a great example of how to make complex topics accessible and engaging. Thanks for sharing this.
My pleasure. And that's all the time we have for today's Tech Bytes in News. Join us tomorrow for another exciting deep dive into the world of technology and science. Goodbye.
Bye-bye.
Welcome to Tech Bytes in News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating story. A teenage programmer's journey, building a Pascal compiler for a transputer in 1993. Incredible!
A Pascal compiler for a transputer? That sounds intensely technical. I'm already hooked. What makes this story so unique?
Well, it's not just the technical feat, it's the context. This wasn't some high-powered lab. It was a teenager, 14 years old, working with his father's homebrew transputer setup. Imagine the resource constraints.
$500,000 Mexican pesos for a single transputer chip in 1992. That's, wow! To put that in perspective, an Intel 8087 coprocessor was a fraction of that cost. Mind-blowing.
Exactly. And the whole setup was incredibly basic. A T805 transputer, 32K of RAM, serial communication only. No fancy IDE, no debugging tools, just raw ingenuity. He started by writing an assembler in Z80 machine code, can you believe it?
An assembler in Z80 machine code? That's hardcore. So he built the tools he needed from scratch. Amazing. What about the Pascal compiler itself?
That's where the real story unfolds. He started with a tiny Pascal compiler from the Byte Book of Pascal, adapted it for the Z80, and then the real challenge, translating P code to transputer assembler. It was a monumental task.
And the challenges didn't stop there, right? I mean, the transputer had this unusual instruction length, varying from 1 to 8 bytes. That must have been a nightmare to work with.
Absolutely. He had to completely rethink his approach to assembler design. Then came the optimization. And initially, his code was inefficient, filled with unnecessary push and pop instructions. But then, he discovered the power of tree generation for expressions, a technique from the Dragon Book. Compilers, principles, techniques, and tools. That was a game changer.
So the tree generation optimized the code significantly, reducing the number of instructions. Brilliant! But even with that, he ran into memory limitations, right?
Yes. His initial compiler exceeded the 32K RAM limit. His father's timely upgrade to 128K RAM saved the day, allowing him to finally get the compiler to compile itself. Talk about a nail-biter.
That's incredible. And he even managed to add floating point support, optimize it for almost 100% speed up, and even used it for ray tracing. This is an epic story of perseverance and ingenuity.
It truly is. He didn't quite finish the FILIO portion, but the sheer accomplishment of building an almost complete Pascal compiler at 14, under those conditions, is remarkable. A testament to his skill and dedication. The source code is even available on GitHub today.
This is a fantastic story, a true inspiration for aspiring programmers. It highlights the power of perseverance, resourcefulness, and a deep understanding of computer architecture. Absolutely amazing.
Absolutely. And it's a reminder that even with limited resources, incredible things can be achieved with passion and dedication. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this fascinating story. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving into a fascinating project, Mount 32 Pi, a bare metal MIDI synthesizer for the Raspberry Pi. It's a really cool project, but the story behind it is even more compelling. The developer is discontinuing it.
Whoa, really? That's a shame. It sounds like a pretty impressive piece of software. What makes it so special?
Absolutely. It emulates the Roland Montana 32, a legendary sound module from the 80s and 90s, used in tons of classic games. Think MS-DOS, PC-98, even Sharp X68000 games. It runs directly on the Raspberry Pi, bypassing the OS for super low latency audio. No complex audio configurations needed.
That's incredibly efficient. So why the sudden halt? I mean, it sounds like a successful project.
That's where the story gets sad. The developer, Dale Winham, says he's been subjected to a relentless campaign of abuse from the VOGNS forum. He's been called names, received threats, had his code stolen, and even his 3D print designs sold without permission. It's a pretty awful situation.
That's unbelievable. Absolutely appalling behavior from that community. I can see why he'd be burnt out. So, what are the key features of Mount 32 Pi before it goes dark?
Well, it supports a range of Raspberry Pi models, from the 02W to the Pi 4. It uses PWM audio through the headphone jack, although the quality isn't perfect, and I2S Hi-Fi DAC support is recommended for better sound. It also has flexible MIDI input options, USB, GPIO, even serial. Plus, it has LCD support, a simple control surface, and even network MIDI capabilities via RTP MIDI and UDP. It's packed with features.
It sounds incredibly versatile, a real testament to the developer's skill. It's a shame to see it end like this. Is there anything users can do to help?
Well, the project is open source under the GNU GPL version 3.0, so people can continue to use and modify it. The developer also asks that people use the discussions area on GitHub for help, rather than the issues section, which is for bug reports and feature requests. He's also asking for respect and understanding.
That's fair. Respect for the creator's work and mental health should be paramount. It's a reminder that open-source projects, while incredibly valuable, rely on the dedication and well-being of individuals. We need to protect our developers.
Exactly. It's a cautionary tale, really. The Mount 32 Pi project is a fantastic achievement, but the story highlights the importance of fostering positive and supportive communities around open-source projects. We need to remember that behind every line of code is a person. Thanks for joining us on Tech Bytes and News. We'll catch you next time.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a really exciting development, Play Canvas React, a new library that lets you build 3D content using React. It's a game changer, wouldn't you say?
Absolutely. This is huge for React developers wanting to get into 3D. The declarative approach is key. It makes building complex 3D scenes much more manageable, right? It's like bringing the elegance of React's component model into the world of 3D graphics.
Precisely. It's a thin wrapper around the Play Canvas API, so if you're already familiar with Play Canvas, the transition should be seamless. But even if you're a React expert with no 3D experience, the learning curve seems surprisingly gentle. They claim you can pick up the basics in a few hours.
That's a bold claim, but looking at the code example, it does seem pretty intuitive. entities, components. It's very much in line with React's component-based philosophy. The example with the spinning box is a great illustration. Simple, yet effective.
I see. Interesting. And the best part? It's not just about simple shapes. They mention you can incorporate assets, physics, even Gaussian splats and audio, all within the familiar React ecosystem. That's powerful.
I'm a little curious though. How does this compare to using the Play Canvas editor directly? Is there a clear advantage to using Play Canvas React?
That's a great question. The blog post highlights that the Play Canvas engine is still the foundation. The editor is fantastic for visual scene building, but Play Canvas React is ideal for a code-centric workflow, especially if you're already deeply embedded in a React project. It allows for seamless integration. You know?
Got it. So it's about choosing the right tool for the job. If you need fine-grained control and are comfortable coding, Play Canvas React is the way to go. If you prefer a more visual approach, the editor remains a powerful option.
Exactly. And the fact that it's open source under the MIT license is a huge plus. It fosters community involvement and ensures continued development and improvement. Plus, they've already got some impressive real-world usage. Snap AI is using it in production.
Wow, that's a strong endorsement. Using it in a production environment like Snap AI shows its maturity and stability. It's not just a theoretical concept, it's a battle-tested library.
Absolutely. And the documentation and examples seem pretty comprehensive. They have a getting started guide, a repo, and even a live playground with examples. It's all very well structured and easy to navigate.
This sounds incredibly promising. It seems like Play Canvas React is bridging the gap between the power of 3D development and the ease of use of React. It's a really exciting development for the 3D web community.
It really is. It's a smart move by Play Canvas, and I think it's going to have a significant impact on how people build 3D experiences. So listeners, if you're a React developer looking to explore the world of 3D, definitely check out Play Canvas React. You won't be disappointed. Thanks for tuning in to Tech Bytes and News. Have a great day.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving into a fascinating discussion about the Rock compiler's ambitious rewrite from Rust to Zig. It's a big move, and there's a lot to unpack.
Absolutely. I'm particularly intrigued by the decision to rewrite rather than incrementally improve. It seems like a huge undertaking, especially for a compiler. What were the primary drivers behind this decision?
Yeah, it's a massive project. But the core reason boils down to the sheer number of independent rewrites already planned. They were tackling issues with the parser, formatter, canonicalization, documentation generation, and even the LLVM code generation. Essentially, almost every component except type inference was slated for a major overhaul. It just made more sense to do a complete rewrite in a new language rather than piecemeal updates in Rust.
I see. So it wasn't just about fixing bugs. It was about architectural improvements across the board. And the choice of Zig, that's a significant shift. What made Zig the preferred choice over sticking with Rust? Or even choosing another language?
Exactly. The primary factor was compile times. Rust's compile times, especially for a project the size of Rock's compiler, are notoriously slow. Zig, on the other hand, boasts significantly faster compilation. This is a huge productivity booster. Beyond that, Zig's features, like its approach to memory management and structive arrays programming, better align with Rock's needs. Plus, Zig's direct LLVM bitcode generation simplifies LLVM upgrades, a major advantage.
That's a compelling argument. The faster compile times alone seem like a game changer. But what about the potential risks? Rewriting a compiler from scratch is inherently risky. How are they mitigating those risks?
That's a valid concern. They're addressing this by prioritizing reliability and correctness. They plan to incorporate fuzzing early in the development process, document as they go, and avoid risky practices like unwrap. They're also willing to sacrifice short-term performance for a more robust and maintainable codebase. It's a strategic trade-off.
Interesting. So it's not just about speed, it's about building a more maintainable and reliable foundation for future development. It's a long-term investment. What are their goals for this rewrite?
Their ultimate goal is to release this rewritten compiler as Rock 0.1.0, the first numbered release. This also coincides with some substantial language design changes planned for that version. They're aiming for a cleaner, more efficient, and more reliable compiler overall. It's a bold move, but it could pay off handsomely.
It certainly sounds ambitious. It will be fascinating to see how this project unfolds and the impact it has on the Romanic language and its community. Thanks for breaking this down for us.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll catch you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into Go data structures, a fascinating look at how Go handles memory and data representation. Let's jump right in. The article starts by explaining basic types like int, int32, and float. They're pretty straightforward, right?
Right, simple types. But the diagrams are really helpful. It clearly shows how int and int32, despite having the same memory layout, are distinct types in Go. That's a crucial point for understanding type safety. And the difference between int and float in terms of their internal representation is also highlighted. Exactly. The visual representation makes it so clear. Then it moves on to structs and pointers, which is where things get more interesting. The article uses point structs as an example, showing how fields are laid out contiguously in memory. It contrasts this with pointer fields, where you have pointers to point structs instead of the structs themselves.
Precisely. Go gives you that control, which is both a strength and a potential source of complexity. It's all about understanding the implications for memory usage and performance. Then the article delves into strings. It's a two-word structure, a pointer to the data and the length. This is clever, because it allows for efficient string slicing without copying the entire string.
That's a really elegant solution. The immutability of strings makes this optimization possible. It avoids the gotcha present in some other languages, where slicing a string might keep the entire original string in memory. I see. Interesting.
Yeah, exactly. Then we get to slices, which are represented as a three-word structure, a pointer, length, and capacity. Again, slicing doesn't create a copy. It just modifies the pointer, length, and capacity in the slice header. This is incredibly efficient.
That's a fantastic design choice. The distinction between length and capacity is crucial for understanding how slices work and preventing out-of-bounds errors. It's all about efficient memory management.
Absolutely. And finally, the article touches upon new and make, two functions for creating data structures. New returns a pointer to zeroed memory, while make returns a more complex structure, often with implicit pointers. The difference is subtle but important.
I think the diagrams really help clarify that. It's a common source of confusion for beginners, but the visual representation makes it much easier to grasp. Got it.
Yeah, it's a great article. It provides a solid foundation for understanding Go's data structures and how they interact with memory. It's a must-read for anyone learning Go. And that's it for today's Tech Bytes and News. Thanks for listening, and we'll catch you next time. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into some exciting developments in the Scroll 5 project. The team has made incredible progress in ink detection and segmentation, and the results are truly remarkable. It's a huge leap forward.
Absolutely. I've been following this project closely. The visible ink in Scroll 5 is a game changer, isn't it? It's so much more dense than in previous scrolls, making ink detection significantly easier, right?
Precisely. It's like finding a treasure map where the X marks the spot is actually visible. This dense ink is allowing for a much faster bootstrapping of ink detection models, similar to what we saw with Scroll 1. Think of it as a massive head start in the race to decipher these ancient texts.
That's amazing! But the segmentation still needs work, I understand. Those sheet jumps are causing some issues, right? The columns are disconnected, and that's hindering the process.
Yeah, the segmentation is a work in progress. The sheet jumps are a real challenge, but the team is actively refining the automatic segmentation pipelines. The goal is to get those beautifully penned Greek letters arranged in neat, contiguous rows and columns.
So what about the content itself? What have papyrologists been able to glean so far?
Oh, that's fascinating. Early indications strongly suggest that Philodemus, our favorite philosopher, is the author. The letter forms, dating back to the 1st century BCE, match his known handwriting style. Plus, words like ye, bodhi, foolish, Wasia, disgust. Pudi, and Azia, life, are characteristic of his writings.
Interesting. And there's evidence suggesting it's a finished work, not a draft?
Exactly. They found a special character used to justify the right-hand margin, a clear sign of a completed text, not a working copy. It's a significant detail.
Wow, that's incredible. So, a finished work by Philodemus, with visible ink. This is a major breakthrough.
It is. But there's still a lot of text to recover. The ink is mostly concentrated on the outer wraps, making detection more difficult towards the center. But the potential is immense.
And what about the significance of Scroll 5's shared features with other scrolls? You mentioned it could act as a Rosetta Stone.
Yes. Scroll 5 uniquely combines features from Scrolls 1 through 4. It has the flat surfaces of Scroll 1, the greasy texture of Scroll 3, and the plate-like surfaces of Scroll 4. This makes it a potential key to unlocking ink detection in other, less visible scrolls. It's a truly remarkable find.
So what's the next step? How are they planning to leverage this discovery?
They're releasing large segmentations generated by Thaumato and the surface traces algorithm. These are available online, and the hope is that improved ink detection models, trained on Scroll 5's visible ink, will be generalizable to other scrolls. It's a collaborative effort, and the community is heavily involved.
This is truly inspiring. The collaboration, the technological advancements, the historical significance. It's all coming together beautifully. It's a testament to the power of collaborative research.
Absolutely. It's a thrilling time for anyone interested in ancient history and technological innovation. We'll keep you updated on the progress. Thanks for joining us on Tech Bytes and News. Happy ink hunting, everyone. Goodbye.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating Go library, Go Multi-Key Map. It's all about handling maps with multiple keys. A really neat problem to solve. Isn't that cool?
Absolutely. Multiple keys in a map. That's not standard Go, right? What's the core idea behind this library?
Exactly. Go's built-in maps only allow one key. This library cleverly extends that functionality. It offers two main data structures, multi-key map and bi-key map. Multi-key map uses a primary key and several secondary string keys. Think of it like a database index, but within a Go map. Clever, huh?
I see. So you can access data using either the primary or any of the secondary keys? What about performance?
Precisely. The beauty is that it maintains O1 access time because it leverages Go's native hash map. The benchmarks show this. Even with 100,000 entries, get, put, and remove operations are relatively fast, although they do increase with size, as expected. The concurrent versions are a bit slower, but still quite efficient, offering thread safety.
And the bi-key map, how does that differ?
Bi-key map is more restrictive. It has two unique keys, key A and key B, providing a different way to structure your data. It's also O1 for access, but the benchmarks show slightly different performance characteristics compared to multi-key map. It seems to have a higher overhead for larger datasets, especially during put operations. Interesting, right?
Yes, interesting. So which one should you choose? Is there a clear winner?
It depends on your needs. If you need multiple secondary keys associated with a primary key, multi-key map is the way to go. If you need a strict one-to-one mapping between two keys, bi-key map is better suited. The choice depends on your data structure and access patterns. The benchmarks are crucial for making an informed decision based on your expected data size and operation frequency.
That's a great point. The benchmarks are really helpful. They clearly show the performance trade-offs. And the library also provides both concurrent and non-concurrent versions, which is a nice touch for flexibility.
Absolutely. The concurrent versions are essential for multi-threaded applications, ensuring thread safety without sacrificing too much performance. The documentation is pretty straightforward, and the examples are clear. It's a well-structured library, and the author encourages contributions, which is always a good sign. I'm impressed.
Yeah, it looks like a solid project. The star history graph shows steady growth, too, indicating community interest and adoption. Overall, a very useful tool for Go developers needing more sophisticated map functionality.
Definitely. A great example of how a simple idea, cleverly implemented, can solve a common problem efficiently. Thanks for joining us on Tech Bytes and News. We hope you found this discussion insightful. Have a great day.
Bye-bye.
Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into the exciting world of rich text editors. Specifically, which one reigns supreme in 2025? The LiveBlogs blog recently tackled this very question, and boy is it a fascinating deep dive.
I'm eager to hear this. So many choices, right? Is there a clear winner, or is it more nuanced than that?
It's nuanced, definitely. The blog categorizes editors into core and batteries included. For a simple composer, a core editor might suffice. But for a full-fledged collaborative app, you'll want something more robust. They highlight TipTap as a well-rounded choice, striking a balance between features and flexibility.
TipTap, huh? Built on ProseMirror, I hear. Isn't ProseMirror notoriously complex?
That's true. ProseMirror is powerful but has a steep learning curve. TipTap cleverly abstracts away much of that complexity, providing a more user-friendly experience. Plus, it's highly extensible, allowing for easy customization.
So it's like the best of both worlds? Easy to use initially, but with the power to scale up when needed?
Precisely. And it boasts excellent real-time collaboration support thanks to YJs, often paired with a back-end service like LiveBlogs for seamless integration. They even have their own cloud solution.
Interesting. But what about other contenders? The blog mentions several, right?
Absolutely. We have Blocknote, a block-based editor similar to Notion, also built on ProseMirror and TipTap. Then there's Lexical, backed by Meta but still under development, so it has some growing pains. Slate is another strong contender, known for its customizability, and used by big names like Discord.
And what about the more established players like Quill, CKEditor, and TinyMCE?
Ah, yes, the veterans. Quill recently had a major rewrite, Quill 2, addressing some long-standing issues. However, it still lacks some features found in others. CKEditor and TinyMCE are feature-rich but come with a GPL2 license, and many features behind a paywall, making them less attractive for open-source projects.
So licensing and cost are significant factors, along with features and ease of use. It sounds like there's no one-size-fits-all solution.
Exactly. The best choice depends heavily on your specific needs and priorities. If you need a robust, collaborative editor with a good balance of features and flexibility, TipTap is a strong contender. If you need a block-based editor, Blocknote is worth considering. Slate offers maximum control but requires more hands-on development, and the established players, while powerful, come with their own trade-offs.
It seems like the blog does a great job of weighing the pros and cons of each, helping developers make informed decisions. This is incredibly helpful information for anyone building a rich text editor into their application.
Absolutely. It's a comprehensive guide, and I highly recommend checking out the full article on the LiveBlogs blog for a deeper dive into each editor's specifics. Thanks for joining us on Tech Bytes and News. We hope you found this discussion insightful. Have a great day.
Bye-bye. Thank you for listening to the daily roundup of Tech Bytes and News. See you again tomorrow. Goodbye.